This is a HP server, a DL380 Generation 8, and I want to talk about thermal paste or not thermal paste. This server has two CPUs, here and here. It's an E5 2670, each of them, they are identical. And this server is ideal for this experiment because both CPUs are next to each other. Both have the same amount of cooling fans here. And I want to try what difference it makes if we run one processor with thermal paste between heatsink and processor and the other without. That's processor 2, and I'm applying heat thermal compound to it because it's a bit a larger chip. I make 5 dots. For a smaller chip I would only make 1 dot in the center, and then I'll apply the heatsink and close that lever so the heatsink gets pressed down firmly and securely. And this is CPU number 1. You can see no heatsink, just remove the dust. So dust would be harmful in this situation. Place the heatsink in and close the lid. And of course the air guide, the plastic air guide. Okay, let's power that on and see what happens. As you can see, I'm running Windows Server 2012 release 2, and at the moment it's just the Windows running, nothing else. CPU load is 0%. There are a couple of peaks, but the speed has been reduced to 1 point something gigahertz. Maximum speed is 2.6. And one amazing fact here is that the power consumption at the moment is only 120 watt or volt amps. There is no power factor involved here, so we are only measuring volts and amps. That's why this device is constantly clicking. It measures the volts, then the amps, and calculates the result. 120 watt for a relatively modern server running Windows and nothing else. So I think in the early days we had CRT screens that used more power than this server. Well, before I start putting load on the CPUs, I want to show you the ILO management page here, where I can see the temperatures of the two CPUs, and both are at 40 degrees Celsius at the moment. Of course, they are not doing much, they are powered down, they are clocked down. Let's see what happens if I start boink, which will put a 100% load on my CPUs. So I started that. Now we should see the CPU load rising. It takes a while until all the jobs have started, but we are already on 26%, 29, 30, 40. And you can also see the CPU speed has climbed up. Server is drawing more power. And one funny bug is CPU speed here. You see it's almost 3 gigahertz, but the maximum speed is only 2.6 gigahertz. And I found that all the Windows 2012 systems have that the actual speed is not right, it's way too high. Because I'm not overclocking this CPU, there is no overclocking possible in this server. And yeah, it's not necessary, but now we have reached 100%. You can also see power consumption is now 400 volt amperes or 400 watts. Let's be generous, let's just forget about power correction and stuff. Okay, so that's the maximum power for this server right now, with a couple of disks with no I/O cards and 2 CPUs at full speed. According to the data sheet, these CPUs draw 135 watts per CPU at full load. So we are still at 40 degrees. I don't believe that. I have to refresh that data here. And now we see CPU 1 is 59 degrees, CPU 2 is 60. It's only 1 degree difference between having thermal paste applied or not. Cooling fans are turning at high speed because we are drawing a lot of power. CPUs are getting warmer, everything plays together. Power consumption has risen to 420 watt, so maybe 20 watt more for the more powerful blowers right now. You can see CPU still at 100%, and temperature has even dropped to 58 for both CPUs. By the way, that's the graphical display of the temperature. So the 2 peaks here are the CPU, so that's the server with all the locations of temperature sensors. It has about, how many? 50 temperature sensors. No, it's not true, there is a gap between, but well, 30, 40. For all kinds, you have even temperature sensors for all the memories. And the interesting one is CPU, which is still 58 degrees Celsius, and that's the same for both CPUs. When we look at the power display here, we see it displays 380 watts. I'm measuring 411 volt amperes, so I don't know what power factor they actually take into the calculation, but it always displays a little bit less than it actually draws. It's about 30 watt less here. And let's go back to the temperatures. CPU 1 is 1 degree warmer than CPU 2, so that's not really a difference, that's measurement error, 1 degree. Okay, let's try something else. As you probably know, thermal paste is there to fill the gaps between the heatsink and the CPU. If they are not absolutely flat, there will be air pockets between, and air is a bad conductor for heat. So you smear a little bit of thermal paste here to make good contact. Here in this case, the heatsink has a large block of copper. It's I don't know, maybe tin plated or something like that. And the CPU itself is relatively big, as most modern CPUs are, and it's also almost perfectly flat. There are people who are grinding this and the cooler with sandpaper to make it perfect, and in that case you really don't need any thermal paste. But what happens if something gets between the heatsink and the CPU? For example, a small hair? Let's try it. So I got here one hair from my arm. It's only a thin hair, maybe you can see it a little bit. And I place it here right on the center of the CPU. And then I make a little sandwich. Is that right? Okay. Is it still there? Yes, it is still there. Okay. Now. And close the lid. And try what happens. Okay. Server is on. Boink is running, CPU is at 100%, and you already see there is one big red peak and the other one is just down here. And we see one CPU is already at 69%, 69 degree, while the other one is still at 40. Let's update that. 69 and 47. So we have now 22 degrees difference. So that's a plausible number. Okay, let's check that again. I don't want to run it too long. Okay, we have 51 for CPU 2 and 69. They are getting closer, but that one stays at 69. I think the quotient temperature here is 70. So because it's relatively close to that temperature, it will probably be clocked down a little bit to make it a little bit less hot. Let's see the task manager. We are still at 100%. Okay. Temperature update. Yeah, you see the other CPU. The other CPU is getting warmer, but CPU 1 is still much hotter. And it is still 69. I think it cannot go any higher. The other 55. That's a remarkable difference. And that's only because a small tiny hair is clamped between the CPU and the heatsink. Okay, let's do the last experiment for today. I will remove my hair, and I also remove the heatsink completely. And let's see what happens now. I think it will not take very long until the server shuts down, or maybe the CPU explodes. So this time I leave the cover open, just in case we get some fireworks, so we can see it. I don't really expect that, but who knows? Power on. Okay, it's not happening very much right now. It's amazing how long it takes. Let's have a look at this panel. If there is a CPU error, we will see that. Not at the moment. I'm surprised how long it takes. Okay, now it got it. It probably sensed the data, got the sensor data from the thermal sensors, tries to cool. It's amazing, still no errors on the screen or here on the display panel. Windows has started. Still amazing. Yep, it is hot. I would say 60 degrees easy. It's amazing, we still have 65 degree on CPU 1 and only 40 degree at CPU 2, but at the moment I'm not running Boink, so the CPU load is more or less nothing. Let me see. Oh no, it's 79%. Why this? I thought I have stopped Boink. Maybe not. Maybe now. Ah, it's even cooler than before. Okay, I stopped Boink now completely. It's only running, yeah, 2% CPU load. Well then, let's just ramp that up to 100%. Let's see if we even can get close to 100. Yes, no. Yeah, that's interesting. It ramps up to 100, but then throttles down to 60, 50. Yes, I think the CPU without the heatsink is now set to idle, but it doesn't go higher than 69 degree. Okay, so you can't destroy it, but it will run slower. Okay, I must say I'm quite a bit surprised by the result. So the server, the main board, the BIOS seems to keep the CPU at the maximum temperature of 69 degree. If that is reached, it will throttle down the CPU or even disable cores. I don't know what exactly happens, but I'm installing the heatsink again now with thermal paste. So the experiment is over. The server can now run in normal mode, but what I wanted to point out is it doesn't really matter if you use CPU grease thermal compound or not, at least not in this server. Even with the thermal compound not applied, it has almost the same, or it has exactly the same temperature as the CPU with the heat compound. That is of course not necessarily true for all computers, but for this kind of CPU with this kind of heatsink, it seems to work without compound. Okay, thanks for watching.